We reviewed a little bit of probability, and we were talking about random variables. And we said random variables are basically functions. So a random variable is a function, and any function we know that it has a domain and a range. Do you remember that? A function has a domain and a range. What are the domains and what are the range of the random variables? Domains are basically the outcomes of an event. If you are rolling a die, the events are number 1, number 2, until number 6. Or if you are tossing a coin, the events, the outcomes are head and tail. So let's consider the coin. We have head and tail. And what it do is this. It will assign it to a real number. So the range is real number. R means real number. For instance, head will be mapped to 1 and tail will be mapped to 2. And we have talked about the probability distribution function, probability mass function. If it is discrete, we have talked about this cumulative function. And image processing course, you already have seen this cumulative distribution function is useful. For instance, we can use it in order to enhance the illumination of an image. Now, we will continue our talk by talking about the joint cumulative distribution function. So we will talk about joint CDF. Now, before I talk about it, do you remember the joint probability distribution function? Now, still you remember the joint probability distribution function? Well, we said that a joint PDF means that we have more than one random variable, and we were showing it with this, f of x and y, of x and y. So it means we have more than one random variable. If you have only one random variable, there is no concept of joint. Joint means that we have two of them. Then we talk about these statistically independent and so on. So if we have a joint PDF, so we have to talk about the joint CDF. So let's see how we are defining a joint CDF. Mathematic-wise, we are writing it in this form. F of x and y is the probability of x, let's put this as random variable, capital letter, x is less than equal to x intersected by y less than equal to y. Or in short, we write it as P of x less than equal to x and y less than equal to y. If you remember, the cumulative distribution function was the addition of the probabilities from -infinity to a given point. So here we do the same thing, but instead of one random variable, we have two random variables. So f of x and y, it is the probability of, we put the condition for x and also we put the condition for y. Now, there are 6 properties that this random variable, this joint cumulative distribution function has. Let's talk about these properties. Let me write them down and ask question from you, and then we answer to each of these specific values. distribution function? It was the addition of the probability from minus infinity to a given point. What is the probability of minus infinity? 0. At minus infinity, we have nothing. So, let's define this. It means the probability of x less than minus infinity and y less than minus infinity. What is it? 0. The probability x is less than minus infinity and y less than y. What is it? No, it will be 0 because x is less than minus infinity. It's not possible. So similarly, what about probability of, the joint distribution function of x and minus infinity? It means x is less probable of x less than x and y less than minus infinity, which is 0. Now, what was the value for cumulative distribution function at plus infinity? 1, because the addition of all the probability should be 1. So what does this mean? This means that the probability of x is less than infinity, y is less than infinity. So what is this value? 1. Now, there are two specific values that we have to know. We will use this ones a bit later. F of joint cumulative distribution function of x and y, x and plus infinity. X and plus infinity. Now, probability of y less than infinity is 1, right? 2, yeah? So this will be cumulative distribution function of x of x. Similarly, this one will be the cumulative distribution function of y. Now, these are very useful because we will use them later in order to calculate the marginal distribution functions. Now, if you remember, we said if we have a continuous random variable, we are calculating something which is called probability distribution function, PDF. And we said if this random variables, like this example that we have, is discrete, then we are calculating, do you remember what was the name for this distribution that we use? We are calculating PMF. PMF is probability mass function. Probability mass function had similar properties as PDF, but instead of integral we were using the summation. Do you remember, given x is continuous random variable, probability of x is equal to a is equal to probability of a point, it is equal to 0. But given x is a discrete random variable, probability of x is equal to a is calculated by this formula. Limit of epsilon goes to 0 of f of x of a plus minus f of x of a minus epsilon. And epsilon is positive. Now, this means that if I have a distribution, a cumulative distribution function, you have seen it actually in previous lecture, and you may remember it even from previous lecture of image processing course. This means that that if you want to know what is the probability value at point A, what you have to do, you read this value, you also read this value, you subtract it. This results, this tells you what is the probability of A. This tells you what is the probability of A. So this formula is telling you that by looking at the CDF, because capital F, if you remember, we said that this is CDF. Now, is it a joint CDF? No, because we have only one random variable. Now, we said in a joint PDF, we have a continuous random variable, we have two continuous random variables, and we look at both of them when we are dealing with joint PDFs. Now, what we can have, if the random variables are not continuous and are discrete, which in most of the cases in this course we are dealing with it because the computers are all digital, so all the random variables are discrete. So we have to talk about something which is called joint probability of mass function. So joint PMF. Now, in here, we are defining it in this form. Is a joint PMF given X and Y are discrete random variables. And similar to PDF, there exist several important properties that you have to know. Probability of what is this? This is a summation, a double summation of probability of X is less than or equal to Xi, or let me call it alpha, and Y is less than or equal to beta, where beta starts from minus infinity till Y, alpha starts from minus infinity till X. Do you know what is this probability function called? What is this called? We just talked about it at the beginning of the class. The addition from probability from minus infinity to a value. It's called CDF. So this is the joint CDF, or well, in case of discrete, you can call it CMF. Now, we are talking about the joint PMF, okay? We are talking about joint PMF. Now, who can tell me what is, for X and Y, probability of X is equal to Xi? What is this? So I have to get rid of the term y in here. So what I do, I say that this is the probability of x is equal to xi and y is less than equal to, let's call it beta. Beta starts from minus infinity till plus infinity. In other words, if I add all the values of y, what is left is the probability for the x. Do you remember? I just erased here. We had this f of x and y, and I said that this is for x and infinity is equal to f of x of x, right? It was property number 5 or number 6 for the joint CDF. So you see this here. This infinity means that now we have to talk about, we have to write down how the bias rule looks like. And then we can do an example. P of x is equal to xi, or x is equal to x, y is equal to y, given y is equal to y, is equal to divided by P of which can be written as divided by the summation of we proved this one on the previous lecture, and we can simply extend it into the joint probabilities. Let me see if you remember the statistically independent variables. If A and B are statistically independent, do you remember what we could say about it? If two random variables are, or any two random events are independent, what could we say about it? Multiplication of them. The joint probability will be the multiplication of them. In other words, for the discrete form, if x and y are statistically independent, then we have the probability of x is equal to xi and y is equal to yi is the probability of x is equal to xi multiplied by probability of y equal to yi. Now, if we have the PDF or PMF, we could calculate the CDF, right? And we have either double integral or we have a double summation, so we can calculate the CDF. Now, question is, what will happen if we have the CDF and we want to calculate the PDF? Or we have the CMF and we want to calculate the PMF. So let's see how we can calculate the, we'll start with the continuous form, how we can calculate the PDF from the CDF. And we start with a single random variable, then we talk about the joint random variables. F of x, which means the PDF of random variable x. This notation means is defined as the derivative of the cumulative distribution function. So if in a question, in a problem, you have the CDF, you find its derivative and you get the PDF. What is what can we say about this? Can it be 0? What is this? Can you read this one? What is this? What is this smaller? What is this? PDF. It's a PDF. It's probability distribution function. So what can we say about the values of them? If it's a PDF, if it's probability distribution function, what can we say about the values of it? So when will it be negative? It is always greater or equal than 0. We know that probability cannot be negative. 0 is a possibility, but it's always greater than 0. Now what last year said, if the integral is from minus infinity to infinity, what is the result? 1. Because the addition of all the probabilities is equal to 1. Now, what is the probability of x is less than equal to a? This, yes, go on. Excellent. It is actually the cumulative distribution function for a, which is the integral from minus infinity till a of f of xx dx. Now, I am sure you can extend the formula and tell me that. Pejman, maybe you tell me, what is this? P of x is between a and b. What is this? The integral of
a to b.
A to b of fx. Now, this is for a continuous random variable, right? And we said that the probability of x is equal to a is the probability of x is between a and a, right? And this is the integral from a to a of fx x of dx. What is the result of this integral? 0. So it's once more proof that the probability of a point when we have this continuous random variable is 0. Next, let's do an example. Let's do an example. Any question? So this is an example and see how you want to use these properties and formulas. For a specific resistor, we have value of, we have a resistor and its value is 10 ohm plus minus 10%. So the value of the resistor is 10 ohm plus minus 10%. Assume any value of resistor, any value of resistance is equally likely. Find Fr of R and lowercase fr of R, in other words, cumulative distribution function for resistor and probability distribution function for resistor. Also, find the probability that a resistor selected at random between the value 9.5 and 10.5 ohm. So I wrote it in a mathematical form, but I read it as a sentence. Find the probability of randomly selecting a resistor value whose value is between 9.5 and 10.5. In other words, what is the probability that I pick up one of the resistors and I measure it, and the value that I measure is between 9.5 to 10.5? You know, when we are dealing with a probabilistic system, and every sentence or every given data is useful, and we have to use it. We have to use it. First, let's start. Did you finish writing the question? The question says the resistor has this value. Do you know what does it mean? It means we have an R mean and we have an R max. What is the minimum? 10 minus 10%, and maximum is 10 plus 10%. So what is the minimum value? 9. What is the maximum value? 11 ohms. Now, minimum value is 9, this is 10, and this is 11. Look at here for a second. Then I will let you do right and wrong. Can I have a resistor whose value is less than 9? No. So what is the probability of less than 9?
0.
Can I have a resistor whose value is greater than 11? No. So what is the probability? 0. So this is representing my PDF. which is f of r of r. Now, question is, what about between 9 and 11? In order to see what is the value between 9 and 11, we look at this. Any value of resistance is equally likely. What does it mean, equally likely? It means that any of the values in here, there is no bias for them. The probability of occurrence of any of them are equal to each other. So if the probability of each of them are equal to each other, what does it mean? It means that it's constant line, right? Because they are equally likely. The value here and here and here are the same. And I call this one alpha. Now, is the PDF ready? Is this the PDF? Yes, it is a PDF. However, it's not finished yet. What is missed here?
The points 9 and 11.
No.
We have to specify whether we look for them on the
No.
zero.
Is it a continuous random variable or discrete random variable?
Continuous.
So what is the probability of having 9? 0. So, but I tell you that this is not finished. What is missed here?
The alpha.
Alpha. We don't know what is alpha. So, let's find the value of the alpha. I know that. How can I find the value of alpha? I have the PDF. This is the shape of the PDF. Very good. Nice.
The integral should be 1.
Yes. The integral from minus infinity to infinity of lowercase fr of r is dr is 1. And we know that from minus infinity to 9 we don't have anything. From 11 to infinity we don't have anything, so it's integral from 9 to 11 of what is the value of f r between 9 and 11? It's alpha dr, which will be alpha r from 9 to 11. This is equal to 1. So I substitute the values. It will be alpha 11 minus 9 is equal to 1. So we get that alpha is 1 over 2. And we knew it. I mean, look at the geometry. The area should be 1. It's a rectangle. This is 2. So the height should be 1 over 2. So the multiplication will become 1. Is there anyone who doesn't know how we got this formula? Do you remember integral? So let me tell you how we calculate it. So I have erased this part to write down how we are calculating the integral of the polynomial. Okay, integral of the polynomial is something that you have to know, but the rest, if it is required, which won't be required, but I will give it to you. So I don't want you to sit down and calculate some problems, some integrals. Now, integral of x to power n dx is 1 over n plus 1 multiplied by x to power n plus 1. Now, and this is for if n is not equal to minus 1. If n is equal to minus 1, then integral of x to power minus 1 dx is ln x. This is the only thing that you have to know. Let's see how I am dealing with this in here. I have integral alpha r dr. Can I tell you what is the alpha relationship of alpha and r? Alpha is a constant, isn't it? It doesn't depend on r. So we can put this alpha out of the integral, so it will be alpha integral of r dr. So it is integral of x dx. What is the value of n? Nasir, what is the value of n here? N. 1. So if n is 1, I write it alpha multiplied by. I put in the cell n1, it will be 1 divided by 1 plus 1, r to the power 1 plus 1. So it will be alpha over 2, r to the power 2. Right? Now, if I have alpha dr, let's see about that. What is the relationship of alpha and dr? Remember, this dr, this shows you that what is the variable of integration. If this variable of integration is r, anything which is not r is a constant. Maybe alpha is changing, but with respect to r, we don't have any r in here, so we put it out. So I will have alpha integral of dr. Can you tell me what is the value of n here? 0, because this is 1, right? This is alpha integral of r to the power 0, 1 dr. So it will be alpha multiplied by 1 over 0 plus 1 multiplied by r to the power 0 plus 1. So it will be alpha r. Right? Right? So this is how alpha r came. Write this part if you want to write it. If you know it, don't write it. And I want to tell you one more thing that you have to know about them. Probability. Is it in the camera? Okay. If, look at here. If integral of fx dx is capital Fx, forget about the PDF, CDF. If this is the case, okay, then integral from a to b of fx dx is fb minus fa. This is known as the first fundamental theorem of calculus. The name of this theorem is the first fundamental theorem of calculus. So this means that what is the integral of alpha dr? It is alpha r. So from 9 to 11, I have to put instead of r 11 and minus instead of r 9. That is how I came up with this. Alpha multiplied by 11 minus 9. This one is always true. It is valid for any type of functions, linear, polynomials, logarithmic, exponential, sinusoidal. Now, okay, I have calculated the probability distribution function. Question continues and asks, what is the cumulative distribution function? Let's see, what is the cumulative distribution function? Now, before CDF or f of r, I am drawing it with green. Before 9, what is the probability value? Before 9, what is the probability value? 0. So, addition of everything from minus infinity till 9 is 0. Now, from 11, look, from 11 and afterwards, I don't have any other probability. So, the cumulative distribution function for any value greater than 11 is that f from minus infinity till that value. What is it? We know that the integral from, if it has 9 to 11 included, what is the result? 1. So any value after 11, the CDF has this value. It is 1. The question is how to connect this one to this point, because we know CDF is continuous. What you can do, you can calculate a few values. For instance, what is the value for f r of r is 10? This means integral from minus infinity to 10. What was the value of alpha? 1 over 2 dr, which is integral from 9 to 10 of 1 over 2 dr, which is 1 over 2 r from 9 to 10, which the result is 1 over 2. It means that at 10, the CDF value is 1 over 2. If you calculate a few points, you see that it's a linear function. But calculating a few points is not enough. We have to calculate for all values. So what we do is this. F r of r is equal to x. This is equal to, if x is less than 9, what is the value? 0. If x is greater than 11, what is the value? Sorry? 1. If the value is between 9 and 11, do I need to put the equality here? Doesn't matter because the probability point is 0. In order to calculate this, I am doing this. F of r of x is the integral from minus infinity to x of f of r of dr, which is the integral from 9 to x of 1 over 2 dr, which is 1 over 2 r from 9 to x, which is 1 over 2 x minus 9. So here we have 1 over 2 x minus 9. This is the equation of the line. Can you tell me, is it linear or not? Nastya, how do you know this is linear? Because x is to the power 1. So we know the equation of the line, you just put some values and calculate it. Already we have calculated for the value of 10, we knew that it is linear. So it says find fr, the cumulative distribution function, find the PDF, and one last part. It says, what is this value? I think this is very easy to calculate. What is this? It says that what is the value what is the probability of having a resistor value between 9.5 and 10.5? It means what is this area? Right? It means the integral from 9.5 to 10.5 of f of r dr, which is from 9.5 to 10.5 of 1 over 2 dr, which will be 1 over 2 multiplied by 10.5 minus 9.5. I just write it in the faster form, or you can do it geometrically. We have a rectangle, the height is 1/2, the width is 1 multiplied by 1/2, it is 1/2. It is 1/2. Do you have a question? Any question? If I ask a question like this in a homework or exam, you can do it, right?
I hope.
You hope, okay. Now, let's get back to the joint PDF. Now this time I have the CDF, joint CDF. I want to see how we can use the joint CDF in order to calculate the joint PDF. Well, I'll wait a few more seconds so you can write it down. So we are going to talk about the joint PDF of X and Y from joint CDF. I have the capital F of X and Y. The question is how to calculate F of X and Y. And the answer is the probability distribution function of X and Y is the double derivative of cumulative distribution function once over X, then over Y. Do you know how to take the double derivative? Do you know how to calculate this? Let me do one simple example. So this is a reminder. Assume f of X and Y is e to power xy, so minus e to power xy, and the question is calculate this. We can write it as we can separate the double derivative into two consecutive and a single derivative. Now, the derivative of f with respect to y, it is equal to, what is the derivative of e to power ax? What is this? Do you remember? It was a multiplied by e to power ax. In other words, what is this a? This a comes from whatever we have here. We put it in here with respect to x. So we write it even d over dx of e to power fx is f prime of x multiplied by e to power fx. This is the general formula. So I want to find this derivative. So it will be the derivative. So this is my f, minus xy is my f. So the derivative of minus xy over dy multiplied by e to power minus xy, because this is the formula, right? The derivative of what I have in the power multiplied by the exponential function itself. Now, you know that if I am taking a derivative, the constant multiplied by variable, the constant can come out, right? Do you remember this? The constant comes out of the derivative. So, is minus 1 a constant? Okay, very good. So it means minus 1 will come out. I am taking the derivative with respect to which variable? Y. Is x a constant with respect to y? Yes. So this is also constant. What is the derivative of y? With respect to y. What is the derivative of y? 1. Like derivative of x with respect to x is 1. So it will be minus x e to power minus x y. Are we okay? This is the first part of the derivative. Now we continue, and it says that we have to find the derivative with respect to x of this one now. Minus x multiplied by e to power minus xy. Now, one more formula, f multiplied by g, the derivative, is equal to f prime multiplied by g plus g prime multiplied by f, right? Do you remember? Peshma, do you remember this formula? The derivative of multiplication is this. Now, I have a multiplication in here, right? So it will be the derivative of minus x prime multiplied by e to power minus xy plus the minus x multiplied by e to power minus xy prime. This is equal to, what is the derivative of minus x? Minus 1, very good. Multiplied by e to power minus x1 plus, but not plus, here multiplied by minus x multiplied by. Now, derivative of e to power minus xy, we already calculated the derivative of e to power minus xy. It's derivative of minus xy, this time over dx. So it's the minus xy derivative multiplied by e to power minus xy. This is equal to minus e to power minus xy minus x multiplied by, now, that's the I want you to do this. Okay? Derivative of minus xy with respect to x. So this is d over dx. Instead of dy, I have dx. What can we say about minus? Constant comes out. What can I say about y? Constant if you come out. What can I say about x? 1 multiplied by e to power minus xy. So if I just simply multiply it, the result will be xy e to power minus xy minus e to power minus xy. So it means the second derivative of f is this expression. Now, You know that in the exam, you have your computer, even yourself. So I recommend you to download the table of the derivative, so you will remember this formula. What is the multiplication? What is the division? Formula of the division. You don't need to memorize any of the formula. Why this is important? Why we need to know this derivative? Because if I give you the joint CDF, now you can extract the joint PDF. Why do I need to extract the joint PDF? Because we will learn, if I know this one, I can see what is the probability distribution function of x, which is called marginal probability of x. I can see what is the probability distribution function of y, which is the marginal probability for y. And if I have them, then I can talk about my system. Then I can, let's say, classify my variables in better classes by using these probabilistic models. Okay. Why? Do you have any question?
In that you can use like online calculators for the
Yes, if you want to use calculator for calculating the derivatives, there will be no problem on that one. You can even use your MATLAB or any other software that you have in order to calculate it, because the aim of this course is not checking if you know how to find the derivative. As you already mentioned, even on the internet you can find the derivative. The important part is that to understand and interpret the question, because the question will not be something like, I give you this and I tell you find this one. The question will be like previous example, which you have to calculate several steps, so you can, if we give you some meaning. Okay? So if you have no question, this is the end of the lecture for today. I will see you